Now, as I was saying previously, object-oriented programming is very similar to our real-world thing. So you can correlate these things in real world, like we just correlated like abstraction with TV remote or smartphones, and so on. And encapsulation, it's just like capsules and so on. Now, inheritance, it is very familiar or very correlated to our normal physical world. So inherit, we know we inherit some properties from our parents. So this is the similar concept in our object-oriented programming as well. So as I was saying, that inherit means we retain some quality from our parents, right? From our father and mother. So this is the thing we call the inherited. Child inherits some properties from their parents. So similarly, here we have this parents and child thing. We call them parent class, child class, or also sometimes we call them superclass and subclass. So main thing here, if we read out from here, so let's say if you want to create a class B which will have similar attributes and method like an existing class A. So we are saying that we have a class A, and of course class means it has some objects, means data, and class means it has some data and it has some methods in direct way. So let's say we want to create another class. Of course another class will have another objects and another, another data and another methods. Now let's say if those data and methods are similar, so we don't want to create the data and methods again, we can just inherit from class A. So that is the concept here. So instead of writing again the program, we can just inherit some portion from another class. So as you're saying that A, besides its own attributes, so then instead of starting from scratch for class B, you can create it by deriving it from a pre-existing class A. So you are inheriting some properties. So this is like something is already there. So instead of reinventing the wheel, you are basically taking some properties from some existing thing. So we are saying that you are inheriting. So as I was saying that inheritance is the process by which one class takes an attributes and methods of another and allow us to add more. So we can also add more features, more data, more methods in our derived class or child class. Of course, we know that child inherit many properties from parents, but of course, child has some other properties as well that was not in the parents. So that is the thing here. We can add more features in our child classes. So it is a way of creating new class for using details of an existing class without modifying it. So we are not modifying the parents. Child is already there. Child and parents are separate, but child are basically inherited some properties of parents. So the newly formed class, we call them derived class or child class. Also, we call them subclass, SUB. We call them subclass as well. And the existing class, we call them base class or parent class, or we call them superclass. So these are synonymous terms. So of course this is a very similar to our real world, right? So that's why we are saying that object oriented programming is very synonymous to our real world. So anyway, as I was saying, the child class inherits the attributes and methods of its parent class, and you can use those as if they were defined in the child class. So just like let's say a child inherited the face structure of his father, let's say. So of course the father's face and child face are different. Of course they are different entity, but they are similar. That means they are inherited from the child's face is inherited from father's face structure. Let's say. Then, of course, the child he can use his or her face in different meanings, in different purposes, so that are not related to the parents as well, the father as well. So that thing is mentioned here. You can use those as if they are defined in the child class. So these are completely, different thing, different entity. Then also a child class can also override data numbers and methods. As I was saying, it can also override it. So we'll be observing this. What do you mean by overriding? Don't worry. And as I was saying, we can also have new methods and attributes. That is completely normal. So let's see the example. So let's say here we defined a person class. So person, we know person is a in general term, a vague word. Person could be any man, any woman, any male, female, parents, child, anything could be person. So we defined a person class, and we defined a class variable as brain equals I have brain. Let's say just like our previous class, and it has these objects, name, age, and profession. Sorry, these are not object. We will call them the data or the properties. Anyway, so these are different data or variable you could say. And these are two methods here. One is talk about you. It will print hi, my name is the name, I am age years old, and I am the profession. And it has another method eat, so you will be printing I am going to eat the food whatever you will provide. And then we are creating a dat class. So if you notice the normal way, it is creating the dat class, and the dat class is basically inherited from person class. So of course we know the dad will have a name, the dad will have a age, a profession. The dad could talk about you. Dad could have talk about you function. That means uh, he can talk. My name is something. I am some value years old, and I am doctor, engineer, or so on. So what we could do, we could write all those functions again here, since this is a new class, that class. But instead of doing this, what we did here, we basically inherited the properties. So if you notice, how did we inherit? So here within our init function, we basically mentioned this particular program. You do not need to understand. So the main thing here, it is inherited. Just believe me. So it is inherited. So this is the super, since it is inherited from the super class, and here we provided the super class person. So it is inherited from person. What is being inherited? Name, age, profession. But again, as I was saying, that it can have new features as well, new data as well. So the new data is salary. In person class, we don't have salary. This is just name, age, profession. But in that class, we are providing a new data as salary. So that's why for new data, we are providing self.salary equals salary. And um, so of course this dat class will have these two methods, talk about you and it. But additionally it has favorite task method. So it will print my favorite task is watching boxing on the TV. So again, if I summarize what we just mentioned, so we have a class like person class, and it has different data, means name as profession, and it has two methods, talk about you and it. Then we define another class named that class, and that class is basically inherited from the person class. So of course, when it is inherited, it has all those features available from person. But then again, it can have additional features. So what do we have additional here? The salary, and then this favorite task method. So if we want to use those things, like let's say we are creating object, the first object dad1. So this is created from the dad class. This is name, age, profession, just like in this sequence, name, age, profession, and then the salary is being provided here. So if you call dad on dot talk about you, now if you notice within that class we didn't mention anything talk about you, right? But it is obviously valid. How it is valid? Since it is inherited from person class, and person has this talk about you function. So when I call this talk about you function, so it basically implemented from this particular function from person class. So it will be printing hi, my name is whatever the name, here it is Asif, I am 30 years old and I am engineer. So if you notice, it is being printed here. And let's say it called now the it function or it method. So it is also in this person class, super class. So just like our talk about you method, it is also being printed. And lastly, we had this favorite task method is also being called. So favorite task method is actually created within that class. So it is just created, just executed in normal way. So if I summarize again, I'm summarizing again and again. Main thing here, You do not need to understand, or you do not need to bother about this program. The main thing here, if the question is what do you mean by inheritance, explain. So I believe you already know what do you mean by inheritance. It is very similar to our real world, just like we inherit some properties from our parents. And then if you want to mention some examples, you can provide examples in written manner. Like you can say, let's say a person class, it has different data like name, age, and profession, and it has different functions like talk about you and favorite task, let's say, or it, let's say. Then you are saying we can have another class named that class, which is basically inherited from person class. So using writing, you can explain the thing. So that is the thing that we usually want from you. We don't want you to write Python program. We basically want you to understand the concept here and to explain in your own words. So here the example was using person and dad. So you can have another example. You can have, let's say, a car class. Car, we know. So a car class could have, like, let's say, a color. We know every car has color, number of wheels, and so on. So these are data, and it can have methods like start. So whenever it called, then the start, whatever it is written there, it will be executed. And then we can define different other classes inherited from car class. So you can provide examples like we can inherit, let's say, Toyota. So we are creating another class Toyota. So of course Toyota, since it is a car, so it would have the color, it would have wheel. So instead of writing again, what we could do, we could inherit the properties from our car class. So that thing we call them inheritance. So that is the thing we usually want. So you need to write it, you need to explain this using plain text English. So multi-level inheritance is something like, let's say, you inherited some properties from your parents, but of course someday you will have child as well. So your child will inherit some properties from you. So this is multi-level. So let's say this is you inherited some properties from your parents. Then of course your child will inherit some properties from you. Okay, so that is multi-level inheritance, and we know that there are generations after generation, so this inheritance will continue. So this is the thing, multi-level inheritance. Now how does it happen here? So let's say in our just our previous example, what we noticed, we have the dad class inherited from person class. So here we have the son class. The son is inherited from dad. So of course we inherited dad from person. Then we are creating another class son that is basically inherited from that dad. That is multi-level inheritance. And let's say within son class we are inheriting everything from dad and we are not changing anything. So that's why pass is written here. But again, don't worry about these concepts. I mean, not concept. Don't worry about the syntax in Python. Anyway, so since this is a class, of course we can create object from this class. So sun1, this is a object, it is created from sun, and these are the initial values like Shamim is the name, 4 is the age, and kid means its profession. So if you notice previously our syntax was here name, age, profession, and salary for that class, and since it is inheriting everything from that and it is passing everything, so that's why we need to provide in that way. So name is, this is the profession, let's say, and this is the salary. So let's say the salary of the son is 0. So even if you notice one dot talk about you. So you may say that we didn't mention the talk about you function within sun, right? We didn't mention it, but it is completely working. If you notice, hi, my name is Shami, I am 4 years old, I am a kid. Now how does it work? As I was saying, it is inheriting. So it inherited the talk about you function from its older generations. So how? So if you notice, the talk about you function was not written within our dat class as well. There is nothing like talk about you function here, but it is written within function person class. So talk about you is just like some features or some method that was written within person class. Now dad inherited it from person, and now son is also inherited from the dad. So this is some properties like that is being available for generations after generations. So that is the multi-level inheritance. Similarly, let's say you call the son one that eats chocolate. So that's why it is printing I am going to eat chocolates. So it is basically using the methods that is written in its superclass. Now here we will be discussing another important term, method resolution order. To discuss that particular theme, we are using this help function. So help is something like it will show you the structure of our object. So sun one is the object here. This is the object we created from the sun class. Now when I'm calling the help function, so it is basically showing the its different properties. I mean, it's different. These are different specifications we could say. Now we will be discussing basically this thing, method resolution order. So let's discuss for a few other things. So as I was saying, that we need to provide these values like name, age, profession, and salary. So when we call this help, so it is basically shows us like son and name, age, profession, salary. So these are different data that we need to initialize. We need to provide some values when we are creating the object from a class. Then method resolution order, we'll be discussing it. Now in the method resolution order, if you notice, first we have this son. So if you notice, we have this, okay, so we have this person class. From person we created dad, and from dad we created son. Okay, so method resolution order means these methods, this is the sequence of searching for methods. So whenever we call a method, we basically search where it is. So this is the sequence in which we will be searching for methods. This is called method resolution order. So this is the order of searching for methods. So it will first search for itself, sun. So since we are talking about a object created from sun class, so that's why it will first search in itself. So that's why the sun is at first. So it will first search here, then it will search its immediate superclass. So that's why next the dad is here. So then it will search for this older generation here. Let's say this is the grandfather. So then it will be searched here. So this is the sequence of searching for a method. So whenever we are calling a method like talk about you or favorite task or eat, so this is the way. So first it will search for itself, then it will search for its immediate superclass, and this process will continue for its other superclasses as well, generation behind generations. And at the end it will also search whether is there any built-in object or not. We know built-in means already defined in Python. I mean already defined in the programming language we are currently talking about. So this is the resolution order, and based on this resolution order, if you notice what is the resolution, what is the methods it find. First of all, there was no method in sun. If you notice, we didn't define any method here. We just mentioned pass. That means we are passing. We are not, writing anything here. So that's why there is no method here. It is basically passing. Next, since we will be searching for dad, so in dad we have this method like the initialization method. That means whatever will supply, and dad has another function or method which is favorite task. And after that, it will search for person. So in person we have eat and talk about you. And let's say, and these are the methods, and the data like the dictionary available. And so don't worry about this thing, main thing here. And important question is, what do you mean by method resolution order? So method resolution order, as I just saying, that it is the way of searching for methods. So this thing we just discussed. So method resolution order denotes the way a programming language resolves the methods or attributes. Python supports classes inheriting from other classes. So you can explain this thing in your own words. The main thing here, when we are inheriting, then of course it will be inheriting some objects, not objects, sorry. It will inheriting some data and methods from its superclass, so from its older generations. Now, what is the way or what is the sequence of finding? This is called method resolution order, and it will first search in its base class. That means in our previous example, sun was our base class, so that's why it will first search within itself search sun, and then it will go generation behind another generation. That, for example, in our previous example, it will first search for our dad class, and if not available, then it will then search for a person class. So that is the method resolution order. We will also see the same thing in multiple inheritance concept. So in just a couple of minutes ago, how we discussed multi-level inheritance. The multi-level means, as I was saying, like say, you inherited some properties from your dad, and then your child will inherit some properties from you. So that is multi-level. Now, multiple means this is also similar to a real world. So, of course, you inherit from two things. I mean, two. One is your father, and one is mother. So that is the thing we are calling multiple inheritance. So you are inheriting properties from both your father and mother. So that is the thing we are calling multiple inheritance. So you are inheriting from multiple superclass here. So let's see an example. Let's say we are starting from another class. Let's say mom class. So mom has name is profession, different objects, and talk about you functions as well. And eat another function name is favorite task, another function is cooking. And similarly, dad is another class of another entity, and dad has also like name is profession, and talk about you and eat and favorite task, let's say. So now you may find that the same variables or same uh, functions are defined two times here. So since normally, in physical world concept, if we say that, of course, mom and dad are two different entity. So mom has this name is profession. Dad has also his name is profession. So of course, dad is not inheriting from mom. That is the normal way, right? So mom has talk about you function. Dad has also talk about you function. So if you notice, these functions are exactly same. This is basically written two times. Similarly, the food function, eat function, basically eat function is also same, but this favorite task, this function is different. So also the name is same, favorite task. Here it is also the name is favorite task, but what it will print, this thing is different. So here it will print my favorite task is cooking, singing, and dancing. Whereas for that it will be printing my favorite task is watching boxing on the TV. So the main thing what I want to point here, that this function both are same, but whatever the function will do, that thing is different. I mean the name and arguments are same. So let's say we will be inheriting from both dad and mom. Okay, so let's say we have this daughter class, and daughter is basically inheriting from dad and mom. So initially we inherited a son from dad. So since we inherited initially son, so let's inherit daughter. So that's why another class daughter. So daughter is basically inherited from both dad and mom, and we are not writing anything. So here it is basically saying pass. That means it will be using all those data and methods available on its superclasses, that is dad and mom. But the question is, if you notice, both dad and mom has some sort of similarities. That means this favorite task, dad has also favorite task. Here, dad has also favorite task, mom has also favorite task. So the same function, but its target is different. Sorry, favorite task. So this one, favorite task. Anyway, so the same function, but the thing as I was saying, that what it will print, that thing is different. Now my question is, which one will be printed if I call, the daughter dot favorite task? Do you understand my question? So we inherited daughter from both mom and dad. So we inherited both mom and dad, the daughter class. Now my question is, if I call daughter dot favorite task, so now what will be printed? This one or this one? Since these two, although the name is same, but the task, that means what it will be printing, this thing is different. So one is cooking, singing, dancing, another is watching boxing on the TV. So that is the confusion here. Which one will be printed? So that question is being answered by method resolution order. So as I was saying, whenever we call a method, so there is a specific sequence of searching. The thing we mentioned, method resolution order. Now let's see what is the method resolution here. Now if you notice, it will first search of its base class as always. As I was saying, that it will first search within itself, that means within the daughter class. Then it is first giving priority to dad. Now we cannot say that dad is being given priority because dad is the earning person or so. I mean, that is not logic like this. Or let's say dad is male or something, right? Since this is programming, so in program there is nothing like dad and mom. There is no difference in terms of which one is male, which one is female, and so on. So there is no racism there. Anyways, the main thing here, it will basically related to how I am defining the class. So here we provided the dad at first and mom at second. So that's why it will first search for dad and then search for mom. So if we write mom at first, it should be capital, and then dad at second, then there will not be any issue. I mean, then the mom will be given priority here. So if you notice, the method at first it inherited from dad. The favorite task is being inherited from dad. Why? Since while defining the class, we provided dad at first. So that's why this favorite task is being inherited. Talk about you. All those functions are inherited from dad at first. Then, of course, some method will be inherited from mom. For example, this cooking. Since cooking was not available in our dad class, so that's why it should be obviously inherited from mom. Like this cooking, this was not available in our dad class, so that's why this cooking will be inherited from mom. But when we have these similarities, like talk about you, eat, favorite task, then of course this will be inherited from dad. So that is the method resolution order here. So that's why method resolution order is important. That means whenever it's called like daughter on dot cooking, so it is basically executing the method from our mom class. And when it is calling daughter on dot talk about you, then it is basically executing the talk about you function from our dad class, since we provided dad at first. So this is the example of multiple inheritance. Now the question could be like, what do you mean by multiple inheritance? So you can provide your own example, any example you would prefer. So method resolution we just discussed here.